Hi, I'm Holly. I'm from Teach All About It, and today we're going to be doing some daily practice for revision. Today we're going to be looking at an exam question and an example student answer for the iGCSE Computer Science syllabus from Cambridge. So in today's question we're going to be looking at something a little bit longer. We have a lot of context for this particular question, and for this one we are going to need to do a little bit of maths. So you are going to try this one first, but I am going to highlight a few things in here. Be aware that they've talked about 8-bit colours, so we are talking about bitmaps. We have been told that for this calculation you can either use 1024 or you can use 1000, and this is because you will not have a calculator. And the other thing you need to do is to show all of your working. And the reason why you're showing all of your working is because we will always be looking to give you marks based upon your working. Okay, so I'd like you to pause the video, have a go at the question first, and then move on and we'll have a look at the student's answer. So this particular student was really close to getting full marks, and the reason why they've nearly got full marks, you can see here that they've worked out the number of pixels. I can identify that they have gone through and they have worked out the number of bits within those pixels. However, at this point we've kind of then gone off on a little bit of a tangent. However, the basis for getting a really good answer is all here. So what we're going to do is we're going to pull this down and we're going to have a look to see how they could have got full marks. And notice on this one it's a 3-mark answer, so it's not just your final answer that's going to count. Your working is important. So what we're looking for is the ability to calculate the total number of pixels based upon a given image. We're then asking you to use the formula. So the formula to calculate the total bits is the width in pixels, the height in pixels, times the color depth. Now remember that the color depth is the number of bits that you require to store each pixel. So it's not the number of colors, it's the number of bits required to store the colors. Finally, we're looking for you to then divide the total bits in order to reach kilobytes. So kilobytes is going to then require some division. And you can see my answer here, but I'm going to work you through this one step by step. Okay, so I'm going to pretend to be the student at this point, and what I'm going to do is I'm going to highlight the important information. So highlighting my important information means that I am reducing this down and getting rid of unnecessary detail. Now this is a computational thinking term called abstraction. So the first thing I want to be aware of is that I have 100 pixels wide and 50 pixels high. So I'm going to work out the total number of pixels in my image. So this means that I have 100 times 50. That's going to give me 5,000. And I might really do a little bit more signposting here. So per image. And signposting is that term that we use for making sure that our examiner understands exactly what we're thinking. We are shouting at them, this is where I want you to give me the marks. So at this point we have taken 100 multiplied by 50, we've then got 5,000 pixels per image. Now the next important thing I want to highlight in here is that these are 8-bit colour photos. Now 8-bit means that that is the colour depth, and if that is the colour depth then I'm going to need to multiply that 5,000 by 8. And that's going to give me 40,000, and that's bits. And again, that is per image. Now 40,000 bits per image is lovely. Now we have then got another important piece of information because we've got 10 photographs, and we want to know how many. So it says calculate the total file size in kilobytes for all of the photographs. So we need to multiply this by 10. So we can take 40,000 multiplied by 10. That's going to give us 400,000 bits, and I might then put all images. Now at this point, we've then been told that actually we don't want to know how many bits, we need to know how many kilobytes. Now what we need to remember here is that there are 8 bits to a byte, and then after a byte we then have kilobytes. So then if we want to do the easy version, we can use 1,000, so we can have 1,000 bytes is 1 kilobyte. So we need to go backwards. So from the top we have divided by 8 because there are 8 bits in a byte because we're currently in bits. So to convert from bits to bytes, we can take 400,000 and divide by 8. Now I'm very aware that we've already multiplied by 8, so technically we didn't need to do that. However, what you're doing is you're showing a step-by-step process. So 400,000 divided by 8. Now that of course leaves us back to 50,000. Once we have divided by 8, so we can put 50,000, and then at this point I'm going to put the word bytes because again I'm signposting. From bytes to kilobytes we want to divide by 1,000. So here 50,000 bytes divided by 1,000, and then we're taking it all the way down again. And that gives us 50 kilobytes, and that is your answer. So one of the things that we're trying to test in this particular type of question is your ability to take an abstract information from a longer question to show your ability to understand our formula. So our formula is width times height times color depth, and then also show your understanding that there are 8 bits in a byte, 1,000 bytes in a kilobyte, and then it will just carry on with 1,000 all the way down right until you get your answer. But be very careful that you look for what they actually want you to output. So would you like your question featured on here? If you've been studying and you have a past paper question that you'd like me to answer and give some examiner style feedback, you can go to www.teachallaboutit.school and you can submit your GCSE, iGCSE or A-level computer science questions for free.